Welcome to Solver Phi.
Okay, so here we see, our graph, and we recall that the coloring of a simple graph is the assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. And the chromatic number of a graph is the least number of colors needed for a coloring of the graph. So, given our graph G here is equal to this graph, we can go ahead and assign colors to our vertices. So our first vertex, let's look at vertex A. So we can assign vertex A the color red. Okay, and then looking at B, well, B is attached to, it's adjacent to A, so therefore B cannot be red, so let's have B be green. Okay, then looking at vertex C, well, C can't be green, but C could be red, so let's have C be red. Okay, and looking at vertex D, well, D cannot be red, right? D is D is hit like twice. There's two this vertex here, C and A, right? Both are adjacent to D, so definitely D cannot be red. So, but D can be green, right? D is not adjacent to B, so D can be green. Okay, and then looking at E, well, E, right? E cannot be red, right? E is adjacent twice to red, but E could also be green, right? E is not adjacent to either B or D, so E could be green. So we have E being green, and we see that we were able to color this graph only using two colors. So therefore, our chromatic number of our graph G is equal to 2. So we have that 2 is the chromatic number of G. All right, take care.